So, our next speaker is an Argentinian, a Cordobés. He's an iOS senior software engineer and tech lead at Toller Technologies, with a rich background in C#, Java, Android, and now iOS since 2014. He's known for driving high-quality software development and effective team leadership. Let's welcome Marcelo Busico.
Hey folks, I guess you can hear me. I don't know if through the microphone or through my voice, but well. Okay, let's get this started. Hi folks, this is Marcelo, and as you can see about me, I'm an information system engineer. I'm passionate about unit testing. Let me just start this. And I'm living in Córdoba. I'm from Argentina, from in the center, in San Luis, in the place of Villa Mercedes, where the La Calle Angosta song is from. So, well, let's get this started. So, how many times have you wondered if you're implementing the right thing while you're writing software, right? Or have you wanted to change code, being afraid of breaking any other functionality? Or even worse, update code made by someone else that you don't even understand. I don't know if you have faced this. I have faced this a lot. So, well, in that case, I would say unit tests and design practices to the rescue. So before starting, let's go back to the foundations. I will to go back a little bit to test concepts because we already take for granted that we all know how to write good unit tests. We all see, for example, the unit test metrics for CI/CD, for example, like the guys have shown before. But well, we need to write really good unit tests in order to have good software quality. So I will do this very quick, so I won't bore you. So test naming. So when you do a good test name, when you have a failure, you know the reason of why is that failure. So that is important to have descriptive test names that will provide quick feedback when the test fails. That is really important. Another thing is when you name the way I usually do is saying what is the method under testing, the condition under testing, and the expected result or behavior, right? And another thing, well, here is a quick example. Following this, I used to follow long test name, but that's not a problem at all. If I have to link, I usually disable that warning as well. Well, regarding the test structure, I usually implement test cases, splitting that into 3 parts in the method itself. So I have the setup part, where I prepare all the dependencies for the test execution, the test part, which is the test itself, and the verification part, which is the part where I have the asserts, right? Here it is a really quick example. I usually include all the time these marks in order to know where it starts and when that part ends. That is really useful as well. It's a little tip, but when you see tests from someone else and you see this, okay, you know I'm setting up, I'm testing, I'm verifying, right? So I think that's a quick tip that you can use for the good. And now the test validation. I mentioned there are 2 kinds of validation: state verification, which usually we center on the return value, the result of the operation. And this is the most common test case that we write all the time, right? And we have also behavior verifications that we want to ensure that the interactions are the right ones, not the result. Maybe we don't have a result, but for example, if we are implementing a cache, we want to ensure that the cache implementation is not going through the actual service to fetch the data. So we need to verify the behavior of that and the interactions. For asynchronous testing, I use expectation with descriptions in order to set up what is expected to be called, and the wait for timeout as well, and the expectation fulfill. That my tip is here all the time, please don't forget to call it in the unexpected path or scenario. I have seen a lot of time, here it is an example, where you see the failure, and I'm calling the expectation fulfilled. If I don't do that, I will have, for example, waiting the test case, in this case for 5 seconds, until that stop running. So that's a little tip that I see this mistake a lot. So the test is passing okay, that is fast. But as soon as something is breaking, this test is really, really slow, for example. Now let's talk about test doubles. That is for Martin Fowler's definitions. So we have dummies that we create. We usually call test doubles mocks, right? But we have different kind of test doubles. So the dummy ones are the implementation that we just create in order to satisfy a requirement for a class, right? We have a protocol. We need to inject something there, and well, okay, we create a dummy that do nothing, but it is there, right? So we don't need to care about the implementation. The fake, which is like a shortcut of, it's like an actual implementation, but with like a shortcut. For example, in in-memory database, right? You have the functionality of saving, storing objects, deleting them, but as soon as you stop the application, it will disappear. You won't have any consequence in your disk with a save file or whatever that will persist after your test run, and you get that value after you run again. So that's a good thing. And stubs that are objects that have fixed responses, and these are the most common that we usually implement, but we call it mocks. But these are the most common and useful for state verifications. And spice is like a level more with, for example, not only stubs, but also records what it was the way that it was called, so then we can verify that. For example, when we have an event tracker and we want to see if the track was called, for example. And another one that is a more complex one is the mocks, which are objects with pre-programmed expectations that you can configure for your use case, and then you verify that these expectations were fulfilled. They were called in the exact way, the same amount of time. So that is the most complex, right? But we usually don't need mocks. So that is an important thing, because I see a lot of implementations saying mock of this or mock of this, and they are not really mocks. Okay, so test properties. These properties sometimes are taken for granted, and they are not. So the unit test needs to be independent. So when you run a unit test, it couldn't affect another unit test. It can't affect another unit test. The execution order shouldn't be important at all. So no matter how the test run, if alphabetically, if randomly, you should have the same result. Fast. Of course, a test which takes several seconds. Raise your hand if you are not having any unit test that takes several seconds in your in your code. I think all you have. So well, if you are having a test that takes several seconds, it's not a unit test. So you need to refactor that. And that is because, and probably because another reason, that should be isolated as well. Because if your test depending on any external system, for example, they could lead to delays, for example. So the idea is to know exactly what are the collaborators' responses all the time, and that should be quick as well, right? That's because we have the test doubles. So unit test, assemble. So this is a process that I follow preparing the talk for today. And in this case, I have the product implementation. In this case, is just returning a false value for now, and the unit test that I start writing. It's like I'm following like kind of TDD, test-driven development. I'm not talking about test-driven development here, but I'm following that. So I document all the expectations that I have with different values and the conditions, and I haven't implemented anything. It just returns false. So after doing that, I started implementing the unit test itself. So I create the first unit test, I put the setup, the test, the verify, and continue doing that. At the end, I have all the unit tests implemented here with all the reasons, take into account, for example, when I call the assert false, I'm providing a reason why it is failing. That is important because in CI, you will see more than it's expected false and was true. You will see a reason, so that is important in the feedback for the CI/CD as well. So please take that into account. So I have all the unit tests implemented, no code yet. And in that moment, I realized in my process, in my mental process, why not having that, the actual code, instead of returning just true or false, returning me the reason that is failing, because I have all that documented in the unit test. So then I changed the implementation of the unit test, but I don't have any implementation in the code yet, in order to return a result. That result could be valid password or invalid password with different reasons, right? So I started with this, and then I passed to that implementation, which, again, I don't have any implementation at all, but for me, it was a learning process in order to do the best implementation possible, and that could match the requirements, right? So having that, I then implemented this, having the unit test, having the interface. I have followed some regular expressions here. I put some raw values in order to use them later in the UI, and I got that, the unit test all passing. So show me the code. Let me show quickly the code. So you don't need to trust me, everything. You can see it well? Okay. So basically, I have this is the old implementation of the legacy password. Let me reuse it right here. This is the old implementation. I keep it like calling legacy password validator, and I have all the old implementation which was returning just the value, right? And then I migrated to this implementation as I show you in the code. In the slide, sorry. And this is the actual implementation that I have. If I run this, it will, well, the first time it is a cold start, but anyway, it will run fast. It took just a few milliseconds. If I run it again, that's awesome because it only took 11 milliseconds to run all these 14 tests, right? And we want to keep this way, right? It's about 1 millisecond per test, right? If you have a big suite, you are not in a trouble. I can make mistakes and make these 14 tests takes 5 seconds, 10 seconds if I don't take care of the thing that I mentioned before. So well, this is the first iteration. I created just a Swift UI interface in order to demonstrate this with a field and the password validator. It doesn't have any architecture yet, but well, here it is the application. If I write some password, I got all the reasons that are coming from the business logic, so I can reuse this in, for example, in a UI kit or whatever module I want to have that. Or for example, if I want to put this same library in a Mac application, I can do it. So for example, if I meet the expectations, I got the green message, right? Okay, and then I evolved this. So I wanted to have like some example of asynchronous tests because I don't have anything here. I was planning to have that here, implemented all each other, but I think we don't have enough time. So let me take a shortcut. So I created here like a method that is called validate password async. And I have the 2 callbacks, one for on success and one for on error. That string is the message of the error, right? Then I use that directly in my UI. When the on success is called, I set that the message and the color different between on error or on success, right? And I have the test for that below because I added the signature, and that is, sorry, let me move this and this one as well. Okay, so I have the async test, and as I mentioned here, it is important to call, for example, the expectation fulfill even in the example of a success, because if I run this right now, that's great. It's success. But well, if I, for example, I forgot to put this on error, I run this, it will be quick as well. I can run all the unit tests, and that's okay. But someone, by mistake, break this, and the implementation is not longer working as expected. And as you can see, the test is still running, but I don't have the failure, even though it was failing. So that was because I have the error, but I didn't call the expectation fulfilled. So that's the tip I mentioned before. And I use the defer usually in order to avoid forgetting calling the expectation fulfilled, because sometimes you put it at the end, you have some return at the middle, or you just simply forget about that. So it's like my pattern is, okay, just start doing the fulfill right now, and then it will be executed at the end of the block. So if I run it again, it will fail, but it will be quick. If I fix the test, it will be passing. So as you can see, it is really, really, really quick. Okay, let's continue with the talk. Come on. I'm seeing the slide. So sorry. Okay, have it here. Okay, thank you. Sorry. So great coding practices, because this talk is not just about unit testing, but also great coding practices that you can follow in order to increase your testability and also your reusability of your code, right? So for example, dependency injection is the most recommended that I use, and that's simple words allow to specify the dependency from outside the implementation, and this can be done using even initializers or properties, and it can be done or not using protocols. You can inject, even if you have just a single class and it's the only kind of instance that you have, you can, even that is the case, you can inject that, because that will allow you to, for example, override that in a unit test with some implementation. You need to make it open, for example, not final, depending on if it is a framework or not, but you will be able to override some behavior if you want to test that, and it is used as a dependency of your system under test. Then avoid singletons. I think that is kind of controversial. For me, singleton is like an anti-pattern because it shares the global state across all the application. We have ways to bypass this. We can create all the dependency graph at the application level and then just share it. So I think it is attainable. And also the thing is the singleton, it doesn't allow, for example, it will generate that independent test that we want, it won't be happening. And also it hides a dependency, because usually you don't pass that dependency in the initializer or property, it is just there. So you're hiding a real dependency that you have in your class. And as I mentioned, if you run the test in other order, it will affect the result. And don't talk to strangers is another guidance that I usually say. You should only call methods of the dependencies that you know and not the dependency of your dependency. That will allow faster refactors. It's a guide you can use, for example, sometimes in a struct or a model, you can chain that, but allowing chaining of method or property is a good practice that will increase your capability to refactor, to test, to mock. Singular responsibility also is a good practice. Having a class that has a single responsibility simplify the testing, reduce coupling, because sometimes you inject an object that has a lot of responsibility, and you don't know exactly what your class needs in order to use that. And so maybe you are using just 10% of this class, and you have all the rest. And if you want to mock that, you need to mock everything. And if you want to refactor that, you will need to take care of that as well. So having smaller classes with just a specific responsibility is great. And it's the opposite of having utils helper. When you usually implement a util helper is like a magnet that all the code goes there. So whenever you think, okay, I'm calling that a string util or an extension, for example, then be careful because maybe you're putting so much responsibility in that. And tell don't ask is another practice that, for example, I usually recommend. So instead of asking to my dependency, okay, for example, I want to calculate the area and give me your radius if you're a circle, or give me your height and width if you're a rectangle, just ask the shape to calculate its area, and they will return. So you need to be as lazy as possible, right? I want to just show it quickly. I'm a little bit overpassed, but well, let me show the last version. So in that last version, I implemented just a view model using dependency injection. Let me see if I can open it quickly. Okay. This is the last one, I guess. So for example, yes. So I have the view, I move it. This view depends on my view model. I created for this. I have the view model that can be reused. I am using here for Swift UI, but if I want to reuse this view model for example, another implementation, I can do it. And I have, for example, some input parameters, which is the password. I'm using Erac Swift here for the example. And I have some output observable, like the validation message and the message color. As you see, the view is as dummy as possible, as lazy as possible. It only takes the values from this observable and reflect that into the UI. So I set up the binding here. When I start using this, I post a validation message. And the good thing here, for example, at the app level, in this case, I changed the implementation. I have different password validators now. I have the original one that we implemented. It is called complex. So if I use that, for example, that will be our original password implementation. If I run this up, so for example, I put some password, I have the different rules. I have created another example just for demonstrating that is a simple password validator, which only validates the length of the password. So I only have one rule. Once I meet it, that works. And I have created the simulation of a remote password validator, which simulates either the complex or the simple with some delay, right? In that case, if I run the application, when I type some password, I start validating and then returns me the value, right? So the good thing is I can change the implementation and specify that from outside even before creating this is the application level. So I created the view, and the view I pass the view model, and to the view model I pass the password validator. And that's all from outside. I don't know which password validator I will be using as a view model. I just will call the password validator, validate this password, and give me the result. I don't care how do you do that. So that is important thing. If I run the unit test here, I can see, again, it is quick. Only 35 milliseconds, 17 unit tests. That's a cold start as well. And if I see here also, I have, well, I can show you all the tests that were run. You see all the tests that I have implemented for different stuff, also for the view model. And the coverage, which I didn't care about that, and I think that is a consequence of doing good practices, is really high. If I see the application, I have the validator with 100% of coverage, the simple password validator with 100%, the complex with 100%, the view, just by chance, had 97. I didn't care about that. I don't care if that is 0, but well, seems the app was run and executed. And the reset password remodel 100%, and well, that's also just by chance. So all the business logic has 100%, but I didn't care. And I don't care. I don't care about that because I'm not seeking for the code coverage. It's just a consequence of doing good code practices, and also having that documented help you to understand a lot of stuff in advance of implementing, and you save time with that. So let me continue with this. Okay. Okay. Well, take some time. Let's go with the fallback. And the fallback, okay. Well, concluding with some advices. Okay. Well, implementing the right thing with unit tests. Writing unit tests in advance have several advantages. One is once you finish implementing your code, you're done because you already have done the unit test and your code. Sometimes it happens to me that I start doing all the implementation, it is testable, but then I say, oh no, I need to write the unit test now, so I'm not done right. So that's one thing. Another thing is you can make questions before having the actual implementation. Sometimes we have product, design, or whatever, saying, okay, we need this, this, this. And when you write unit tests, you start thinking and learning about the business logic, and you can make questions in advance. So you don't need to refactor later because you realize after you have done all your code that you need to change it. So that's a good thing. Even when I start thinking in the test name, even without implementing the test cases, I came up with a lot of questions to product. I have folks with that have worked here in my company that I can say they can say that it's true. I make the product owner crazy with questions, and that happened because I have realized of this because of this process. And and capture requirement using unit test. All your knowledge, all your gained knowledge, it will be there forever until someone can change it. So if anyone changes your code by mistake, it will be there and it will run with every test, with every build. So that's a good thing that you need to consider all the time that you write tests. You are putting your knowledge in your code. But before going to the question and answers, I have to say some special thanks. And the special thanks goes to, well, first of all, to my family, Alex, Steffi, and Luz, who support me to be here, and also my dog and cat, my dogs, Luke and Pierino. The first one is like a cat because it jumps to my bed all the days. Then to Nau Zapata, who encouraged me to be here. I don't know where is. Thank you, Nau. He was the one who invited me first, so thank you for that. And it's a pleasure to be working with you as well, all these almost 4 years. And again, Toller Technologies, which is the company who was formed. It's a great software company which has talent from all the Latin America. We work for United States clients. Yes, they were supporting me to be here as well. And last but not least, the sustainable team, Jose, Facu, I only have picture with you, but also Cynthia and Sophie that were organizing this event. So if you want to have the unit test code, I have tags and all that kind of stuff. You can scan this QR and it will be, it is available already, so you can get it. I will wait. And that's all, folks. Thank you so much.
All right, so I have some questions for you.
Okay.
First one says, what are your suggestions for knowing what to test when you're first starting to write tests?
Okay. Well, basically, it's more important that you start thinking. Maybe you don't have what to test yet, but you start knowing the requirements. So when you start writing the unit test, you will know in advance probably what it will be the protocol or the implementation, then later you will need. So I think the important thing of this is the learning process. Coding is a learning process, so that enables you to learn before. So I don't have like just one question, but as soon as I see a requirement, I start thinking, okay, maybe I don't write the unit test first, but I think about them in my head and all the possibilities, and then maybe document that, and then start writing that in code for unit tests and then for implementation. I don't know if that answered the question.
Okay. Sorry.
No problem.
Couldn't the password validator be implemented as immutable functions instead of a class?
Yes, yes, of course. Right now, I did it like a class because, for example, I wanted then to change that and implement a protocol, for example. And also, in this case, I don't keep the state, so that is not really important. But yes, sometimes I create unit tests just for struct and to validate that. Yes.
Okay. How do you handle integration tests? Do you have different testing plans for
Yes.
different kinds of tests?
Yes. Well, in this kind of testing, the integration test is if you have the test pyramid, you have like the base of that is the unit test. Maybe you already know about that. Then you have the integration testing, and in the top you have the UI test. The integration test is basically changing what you are injecting. So instead of injecting just stubs or mocks or doubles, maybe you start injecting the actual object that will collaborate between them, and you start testing that kind of stuff, even with unit tests, but with another level of isolation. So you call it integration test. It runs like a unit test. You don't run like UI in the application, but you start having the real collaborators to test them. And you have that split in another test plan because maybe they took more time, maybe they are a little bit more unstable than unit tests, but that will be a good sign of the health of your integrated product.
Okay. Sometimes you cannot avoid singletons. For example, when you're working with Bluetooth protocol. How can you still cover your code with tests in that case?
Yes. Well, what I usually recommend that is to wrap that. You can make like an implementation. Do it like, for example, you can have a protocol, you have the live implementation or whatever you want to call it, and that is satisfying that protocol, and you hide that implementation there. So you have the singleton there, but you don't actually test that in your unit test. Then you inject some stuff for that, but maybe in the integration test you can do it, but in the unit test you can mock it if you wrap it in another class.
Okay, I think this is the last one. It says, how do you deal with fake test coverage, as in code that executes during test but isn't really tested?
Yes. Well, as I mentioned, coverage is not the main reason to me to write unit tests. It's just a consequence. Maybe it's more for managers or if you want to have a dashboard with the coverage in order to not decrease the coverage. But for example, one thing that you can do is to put some validation on what like file patterns that you want to have, like, okay, if it is a view model or it is inside this folder, I want to have a unit test measure for this because I want to ensure the coverage of the business logic is high. But for example, I can ignore all the views, for example, and that is a way in order to like have a more accurate coverage if you want to really measure. Again, that is nothing for developers. It's like just for reporting. If you are coding just for the coverage, you're not doing a great job. I have seen code with 100% of coverage that it couldn't be understood, it couldn't be modified. So I think that the important thing is the good practices. But yes, you can do it that.
Okay, no more questions.
Okay.
Thank you so much, Marcelo.
Thank you.